All right. Good morning, everyone. Today is Wednesday, September the 29th. We have our exam 2 review today. All right. So your exam is 12 questions worth a total of 36 points. Yeah, so let's get to it. All right. So you have a question on your test to find the determinant. Everyone, quickly, what is the determinant of this matrix? I haven't uploaded part 2 yet. That's why you don't see it. All right, yes, it is negative 23. Yeah, the answer to this one is negative 23, right? It's 2 times 1 is 2. So go ahead and just write this out. Yeah, 2 times 1 is 2 minus negative 5 times negative 5 is positive 25. And then 2 minus 25 is negative 23. So yeah, that is the answer right there. Yeah, that's a freebie, I think. All right, next one, you're going to have a bunch of blanks. So this one says if the X matrix is this, the inverse of A is equal to this, the product of the matrices blank the identity matrix. Therefore, X and A blank inverse of each other. So this problem wants you to compare these matrices to determine basically if it's an inverse. So how do we know these are inverses of each other? We can multiply them, and when you multiply them, what do you get? So if you multiply them, if you get the identity matrix, it tells us they are inverses, right? So everyone quickly go ahead and multiply this matrix and this matrix together. And you can go ahead and stop once you determine if it is or is not the identity matrix. Let me know what you get and what you find out about these. I'll give you about a minute at the most. So Enzo, why aren't these inverses? Like, how do you know? Like, what's the giveaway? So the product is not the identity matrix. Yeah, so row 1, column 1, that first number is not a 1. Yeah, so once you see that, you don't really have to go on to the rest of the problem, right? Yeah, so you get, someone says you get negative 7 over 3. So let me just show that work. Yeah. So I didn't have to do all this. Like, if you just check that first element, if that's not a 1, it means that this is not the identity matrix. So the product of the matrices is not the identity matrix. So make sure you use the correct grammar too, right? The product matrices is not the identity matrix. So remember, is singular, R is plural. It does matter because this is like a drag and drop for the words. So yeah, this either it is or it is not the identity matrix. Therefore, X and A blank inverses of each other. So because it's not the identity matrix, what does that tell you about X and A? Yeah, they are not inverses of each other. They are not inverses of each other. So yeah, let's say that this did equal the identity matrix. You would say that it is the identity matrix, and then you would say that therefore X and A are inverses of each other. All right, matrix addition. This looks like a freebie, right? How do you add matrices? Yeah, straight across. You just add their respective elements, right? Yeah. So super straightforward. This is a freebie in my opinion. Nobody should miss this. Just make sure you don't accidentally point to the wrong value, right? So yeah, we're doing 5 plus -4, -6 plus -1, 5 plus 1, 2 plus 2, and so forth. So yeah, this is a freebie in my opinion. Super easy. Okay, matrix multiplication properties. This problem wants you to show the associated property. So you're going to be given 3 matrices. You'll be given fill in the blank. And they want you to show that the quantity A times B then times C is the same thing as A times the quantity B times C. So you're going to have to fill in these blanks with, well, the correct matrix, the correct matrices. How do I find this first blank? What do I do? Yeah, we just do A times B, and I trust everyone by now can multiply matrices. If you can't, I think you missed something this unit, big time, right? So A times B. So yeah, we just do the math and we get the answer, right? So yeah, that's the first blank. All right, how do I get this blank right here in our second equation? How do I get that? Yeah, B times C. I should have written B times C before actually doing the work, but you'll see that I did not rewrite it. I should have. That's my fault. Because if you don't rewrite it, there's a chance I could make a mistake, right? So we always want to rewrite it before actually doing the math. Yeah, we shouldn't go right to the work from the problem. Just keep that in mind. It's easy to make a mistake here if you don't rewrite it like I did for A times B. But, we did the math, and that's what we get. So uncover that. What should be true about both of these blanks? What should be true? Yeah, they should be the same. You're right. They should be the same. So maybe it's a good idea to just multiply this matrix times this matrix to see what we get. And that's what I do for the work over here. So there's the work, and then we get this answer. And then same thing for the work. I'm going to multiply this matrix times this matrix just to check the answer, right? We're expecting it to get the same answer. If we don't get the same answer, something is wrong, right? Either we multiplied wrong, or our initial blanks here and here, one of them or both of them could be wrong. So it's a good way to check to see if we're doing it right. And hey, they are the same. Good thing. So that's those blanks. Yeah, you'll have one of these problems. Pretty straightforward. All right. Row operations. What matrix results from the row operation represented by -2r sub 3 plus r sub 2? So here's a question for you. Given this row operation, which rows do not change? Rows 1 and 2. Anybody agree, disagree? Row 2 and 1. Row 1 and 3. We are in a lot of disagreement here. Anybody else? Rows 1 and 2 don't change. Isaiah's like, wait, dot, dot, dot. So which rows do not change? So Isabella says, row 2 is the one that changes. So Isabella, how do we know that row 2 doesn't change? Or anybody? How do we know that 2 is the one that changes? Because it's the last term in the operation. Yeah, so this is important, especially when doing reduced row echelon form. We only change the row that is listed last in the operation here. So row 2 is the one that changes. Does row 3 change? No. Does row 1 change? No. Does row 2 change? Yes. Row 1 and row 3 do not change. So in my answer, I am going to uncover just row 1 and row 3. And now we have to do the math. Now remember, this is just temporary. Even though we're doing -2 times row 3, it doesn't mean we're going to change it permanently. We're just doing this math to then combine with row 2, because row 2 is what's changing. So all we're going to do is -2 times 2 is -4, and then -4 plus -5. Sorry, I'm already doing the math in my head. Sorry. -2 times 2 is -4. -4 plus -1 is -5. All right. And then we are doing -2 times -2 is +4. +4 plus -1 is +4 plus -1 is +3. Yep. And then the last one, we are doing -2 times 0, and then 0 plus 5 gives us 5. Yep. And I would suggest showing, kind of like I showed here, showing this so we don't make mistakes. And maybe we should set this up for each one before actually doing the math. So yeah, set this up, set this up, set this up, and then, do the math to get this number, do the math to get this number, and so forth. So this is important, guys. This is really important to understand, because if you don't understand this concept about which row changes, which rows stay the same, your TGA number 1 is going to be impossible. So you guys make sure, I say this many times, that these live classes are great to learn how to do these problems, but you need to still go through the learn and practice modules to work out all the examples they present. Now, the modules may not demonstrate solving the problems the same way that I do, because I like the way that I do it, best, right? It doesn't mean it is the best way. It's just how I like it. I think is easier doing it my way than the modules, and that's okay. And you can do it the way the module does. You can do it the way that I show you. It doesn't matter to me. But you need to practice these, and if you want to be successful in this class, and you need to do that. Yeah, he the best. And I do agree with you. The modules are confusing many times, and that's okay. If you don't want to read how they do it, that's fine. All I ask is you just do the examples, because they have the examples and they have the answers. At the very least, work them out the way I showed you, just to see if you get the same thing. You don't have to read their explanation on it. A lot of times it doesn't make any sense, and a lot of times they skip steps. a lot of times. Like they skip many steps. You're like, how did you get from here to here? And I'm like, if I was grading that person's work on a TGA, I'd mark it wrong. I think you cheated because I'm like, you didn't show enough work. But I don't know. Maybe I'm overcritical sometimes when I grade work. Because, and by the way, it's that I'm maybe overcritical when I grade TGAs because I want you to learn. I want you to learn from it. I want you to see mistakes and maybe what you should have done. Because if I just let certain things slide because they're maybe technically correct, or you can argue it's also correct, um, you won't learn as much, in my opinion. And for me, grading harsh, I think you'll benefit in the end from it. Um, like when I taught in person, I gave no partial credit. Like you took a quiz or a test, if you missed a minus sign, I marked the whole thing wrong. Like I was brutal every time I graded, and students hated it. But then they learned that you need to be perfect to get points, and overall, the class did do a lot better in the end. It's just at first you definitely wouldn't like it. Yes, you do use matrices in coding. They are called arrays, and you can do 2D arrays, which is what we do, matrices. You can also do three-dimensional arrays. So remember, it's like a cube. They have depth. You can even have like four-dimensional arrays, five-dimensional arrays. It gets kind of crazy, but it's a great way to store a table of values. So yeah, they are used quite a bit in coding. Alrighty. All right, you'll be given a problem like this. You'll be given like scalar times matrix equals matrix, and says what's the value of a. So let me give all of you a minute and a half to solve this problem. Minute and a half. Ready to go. All right. Someone want to tell me what we do first to solve this problem? Any ideas? Okay, if you're not done. Hmm. Huh. Um, Enzo, your approach. I don't know if your approach is going to work. That sounds really weird. Yeah, I don't think multiplying by the inverse on both sides for that first matrix is going to work. Yeah, I wouldn't do it that way. I think you're making everything so much harder. And there is a way to do it, and I can kind of see the path that you're taking Possible, yes. Definitely not the best. Divide C by A. No. Anybody else? Anybody else see something else we can do? So you had these on your modules. I'm guessing a lot of you didn't go through these. Nope. The problem's a lot easier than a lot of you are making it out to be. Anybody else? Properties. Yeah, there's a property that could work, I think. Maybe. Lizeth, why? So she said set the first scalar on the left equal to 2. Why would you do that? Because we need the first to equal the other. But why 2? Like, how did you come up with 2? And you're not wrong, by the way. I want to know, how did you get 2? All right, you were on the right track. The reasoning is not right. Well, yeah, the reasoning's kind of iffy. So let me have you look at this. So, we have this is a scalar times a matrix equals a matrix, right? We need this, whatever number in here, we need this times this matrix to give us this. And you may have noticed that these elements are just double, right? This is just double. So our goal really is to make these matrices the same if possible. So how can I make the second matrix identical to this first matrix? What can I do to this second matrix? So multiplying by a half, but remember, we can't just multiply something one side. We have to, if you do something to one side, you must do it to the other side, unless you can factor. So remember, a scalar is just multiplication times every element. So couldn't I just GCF, greatest common factor, a number out? So like Brady says, pull out a 2. Look at this. We can GCF a 2 out, right? So we can pull out a 2. So divide by 2, divide by 2, divide by 2, divide by 2. So we can put the 2 out in front. Everyone see that? So we did the opposite of the scalar multiplication, right? So if we did the scalar times the matrix 2 times every element, we get back to the original. So we just GCF the common scaling value. We can do that. And we did talk about in class. Now does everyone see that these matrices are the same? So now we can do what Lizeth says, and we can set the scalars equal to each other, because for this equation to be balanced, these scaling values need to be the same. So this needs to be equal to 2. Because if they both equal 2, we would have 2 times this matrix and 2 times this matrix to give us the balanced equation. So this is where we set the scalars equal to each other. So again, I encourage all of you to go back to the modules, learn and practice, and work these problems out that they give you. Every problem is going to be different, but you know, the problem is a lot easier than you probably thought. And then we just solve, right? Add 6 both sides, and then we can multiply both sides by 7/3 to do it in one step, or we can multiply both sides by 7. Then divide both sides by 3 and reduce, which it already is. What's the wrong answer? Oh, okay, it's right. It's not reduced. It is reduced. 56/3. Yeah, it doesn't reduce any further. Okay. It kind of, you know, at quick glance, right? Seeing this number over 3, it makes you kind of wonder, can this go into 56 evenly? Well, the answer is no. And I know that because the division rules, 5 plus 6 is 11, and then 1 plus 1 is 2, and 3 doesn't go into 2, so I know it doesn't go into 56. Yeah, there's tricks you should have learned like in grade school about multiplication division rules of how you know if things go into other numbers evenly. All right, let's go. All right, you'll have to do a Cramer's rule problem. All right, so here's the formulas, and there's the equation. So I would like everyone to derive determinant d sub x, and determinant d sub y. I'm going to give you all 1 minute to do so. All right, everyone should have these 3 matrices derived. Now on your test, they're going to present it different than how we showed it in class. If you did the quiz, and you would have seen how they present it. Now, if you haven't done the quiz yet over Cramer's rule, yeah, this will look weird. But we know that x is d sub x over d. So we want the determinant of that matrix. So that's how they want you to show it. So your work should have shown, remember, vertical bars means determinant. So you're doing determinant of these numbers, right? That's your d sub x value. And then your determinant D is this matrix, right? So remember, vertical bars means determinant. Determinant of this matrix, determinant of this matrix. So, and this is drag and drop, by the way, in your test. So you'll have to, I would suggest setting these up first. And then once you have them set up, then it's easy to say, oh yeah, D sub X will be on top. And that's what the setup was. Determinant D, well, that's what I did to set it up. So it's easy to pick out. Don't try to pick out the answers without first actually setting it up. You're making more work for yourself by trying to think about it. You'll make mistakes. So, same thing for the y. We're going to have d sub y in the numerator, and then again, your determinant d is going to be in the bottom, so no surprises, right? So yeah, there's the first blanks for x and y. And then your next blank, they want you to actually show the math. They want you to show 18 times 2 is 36 minus negative 3 times 7 is negative 21. But two negatives make it a positive, right? So your next blank on the top is going to be this. And then for the bottom, 2 times 2 is 4 minus negative 3 times 5 is negative 15. Two negatives make it a positive. So that's that first or second blank, top and bottom. Same thing for this one, right? We do the math. And then for this third blank, they want you to actually do 36 plus 21 and 4 plus 15, and then do the math top and bottom for that one as well to get you those numbers. And then for the final blank, they want you to actually simplify. So that is the flow of work they want you to show on that quiz, which all of you should have done by now, and also on the test, right? So pretty straightforward if you understand Cramer's rule and the equation. And yes, I will allow you to use the formulas on your test if you have them written down. Partly because I couldn't enforce it otherwise, right? So I'm okay if you use the formula. Yeah, so yeah, be careful because these are drag and drop, but they're going to have choices where you make a mistake, they may have that choice as one of the drag and drops. So that's why you want to set these matrices up first and then look at, all right, d sub x is whatever my setup was, right? And then that goes on top. Matrix determinant d is going to be whatever I set up that goes on bottom, and then go from there, okay? All right. Okay, you're going to have a problem to decide if these matrices are defined or not defined. So I give you matrix A, B, C, and D, and then I give you like in the bank of choices, and you have to drag these to either defined or not defined. And this is talking about products. What does products mean? You say, what's the product? What are you doing? Yeah, you're multiplying. So this question wants to know, are we able to multiply these together? Yes or no? If yes, it's defined. If no, it's not defined. We're talking about, the products, but you could have problems that involve addition, subtraction. So, hopefully all of you know how to add or subtract matrices, and you should know if you can add or subtract matrices, right? But let's look at these. Let me give you all 30 seconds, we'll say 45 seconds to decide if these are defined or not defined. Ready, go. All right. A times, okay, hold on. Let me do something first. We're going to label this as choice J and choice K. That way there's no confusion and we're not writing defined, not defined every single time I ask this question. So you just say J or K. All right. A times B, is it J or K? J. It is. All right. What about B times A? B times A is K. All right. Good. A times C. A times C is K. Good. B times C. J. What about C times B? K. C, which one are we on? C times D. J. And then D times C. J again. All right, good. All right, who got all these correct? Good, good. One way I suggest doing these is to write them down. So we want to label them. So the start of this, what we should have done was actually labeled this. This is a 2 by 2. This is a 2 by 3. This is a 3 by 1. And then this one is a 1 by 3. So we should start off by actually labeling them what the dimensions are. And then I just make a list of all the ones that we're comparing, right? So then we just write down 2 by 2 times 2 by 3, 2 by 3 times 2 by 2. So what I do is I just go through and I just write them. I don't do any checks yet. I think it's easier just write them all down. And then what we can do is just go through and remember, for multiplication, we're just comparing, are these numbers the same? And if they are, it's defined. If they're different, it's not defined. So make it easy on yourself. Did anybody do it that way? Let me just anybody do it that way? Some say yes, some say no, some say sorta. Yeah, I think it's easy to. The more work you can show on paper, you're reducing the chances of making mistakes. So that's how I would do it if I was in your shoes taking this test. All right, let's go on. Freebie. How do we do this? -9 times matrix A. So what is -9A equal to? Yeah, we just multiply 9. Yeah, distribute 9 times every element is the wording ultimate for it. Yeah, we just do -9 times every element. -9 times every element. So yeah, we just get that, right? So this is a freebie. Nobody should miss this problem. Nobody. If you do miss this problem, I hate to say it, but maybe this class isn't for you. I don't know. That's kind of harsh, right? Because it's possible to make a mistake, right? It is possible that you just multiply them wrong. But if you miss this concept of how to do the problem, this class may not be for you. And it worries me. So I expect everyone to get whatever number this is on your test correct. That's a freebie in my opinion. Okay, inverses. We got 15 minutes. Determine the inverse of matrix C. Make sure to write any fractions as simplified fractions. Now this should go without saying. You should always simplify your answers. If you don't, it's not finished, but it does state it, I think, on your test. Make sure you simplify. So here's the formula to find the inverse. So we have to do the determinant of matrix A. Just quickly, everyone try to solve this quickly, and chat once you have the answer, put what you get for the determinant. So we got a 45, we got another 45. Oh, we got more 45. So yeah, that's probably right. Yeah, 45. All right, so it's 1 over 45 times this matrix. Now, don't forget, like we learned Friday at the noon live lesson, these diagonals trade places. So, -5 and -1, these trade places. The 8 and the -5, they stay in the same place, but you just flip the sign. So this 8 becomes -8, and this -5 becomes +5. And then we just distribute, right? We distribute the scaling value to every element. And then don't forget to reduce your fractions if you want credit. Make sure that your negative is either out in front or in the top. I want to say the test should give you credit if you put the negative in top. I am fairly confident that if you put this negative in the denominator, it will mark it wrong. So general rule, you never want to have a negative number in your denominator. So like if your determinant was negative, your final answer that's reduced, it better not have the negative in the denominator. It'll be wrong. Okay. But yeah, if you put it in the numerator or out in front, it should give you credit. If you're like me and you like putting the numerator, the negative in the numerator, and it doesn't give you credit, message me on Skype and I will fix the grade manually. Yeah, to be safer than sorry, just put it out in front. If you do put it in the numerator and you want to just roll that dice, let me know if it actually gives you credit. I hope it does. All right. The hardest question on this this test is the word problem. So I'm going to take you through one. Yeah, it's kind of strange. Well, not strange. It's hard to understand if you haven't done it before. But so be given two matrices like this, and it's going to describe some scenario, such as this matrix A, representing the quantities sold of 3 sizes of shirt styles. So here's matrix A. All right, so these numbers represent the quantity sold of 3 shirt styles. All right, now we have rows and columns, right? So looking at this matrix and what it says here, what do the columns represent in this problem? So how do you know? And Isaiah, are you just going along with Enzo and Isabella because they're usually right? Like, how do we know? It says in the problem. It does say in the problem. And what does it say in the problem? So it looks like Isaiah is changing his answer. You're saying the 3 sizes are the 3 columns. Is that what you're saying, Isaiah? You're changing your answer? Brady's also agreeing with Isaiah's changed mind. He's saying that the columns are the sizes because we have 3 sizes. No, if you scroll up there, there's I read styles. Yeah, they said They said styles first, both Enzo and Isabella, I believe. Right? Yeah, 3 columns, 3 sizes. So look at this. It says the quantity sold of 3 sizes. We don't have 3 rows. We only have 3 columns. So by default, the columns must be the sizes, right? Column 1, column 2, column 3. So maybe small, medium, and large. So once you determine the labeling, we should label it. So the columns, these are your sizes. All right, these are your sizes. And I see a lot of you in chat, Harry said the rows, right? So that means if the columns are sizes, those 2 rows are the styles. So we're going to just do styles. All right. Hopefully that's clear by now. And then the next part of the problem says another matrix could represent the price. So these are the prices. Now these are the prices of the shirts and the color being blue or green. So now we're talking about color and not style. So this one represents something a little different, right? So for the sizes, is the sizes the rows or the columns? And why? So why do you think the columns are still the sizes? So let's read it again. So this represents the price of the shirts. So we got to be careful because it in a way I could see why some of you think what our headings are price and the other heading is the color. The elements themselves, these elements actually represent the prices. So these are the prices of the different sizes and the different colors, not the different styles though. So again, which labeling for sizes, the columns or the rows? The rows. And we know it's rows because why? Because we have 3. We have 3 sizes, so it has to be the rows, right? We have row 1, row 2, and row 3. So that means the rows, those are the sizes. And now the columns. So the columns, we have 2 choices, blue or green. So these are the columns, right? There's two colors. We have 2 columns, so we're just going to call this colors, right? The columns are the colors, whether it's blue or green. So I'm just going to write colors. But I do see why maybe you may have thought that this was the price, but the elements themselves are the actual price of the different size color. So maybe, this is maybe row 1 is small, this is medium, and this is large, and this is blue, and this is green. So a small blue maybe costs $6. A small green may cost $8. A medium blue is $10. A medium green is $9. a large blue is $15 and a large green is $12, for example. So, by looking at these, it kind of makes sense, right? It's, as you get a bigger shirt size, it's going to cost more money. And it also looks like the green color costs, well, it costs more here, it costs less here, and it costs less here. So it looks like they just charge more for the small green than they do the small blue, for example. But anyway, I guess that kind of makes sense. So you really have to label your matrices properly. And then you're going to have fill in the blank. I believe you're going to have a bank of choices, so it makes it a little bit more tolerable. But the last part says, how can these matrices be used to determine the price of the 3 sizes sold? The product will be a 2x2 matrix. All right, so we need to do what with these matrices? You mean too much with O's? I'm going to correct you. Or too much, not single O. Yeah, there you go. Multiply them together. So it does say that we want a 2x2 matrix solution. So we can check A times B or B times A. We can figure out, which combination will give us a 2x2 matrix, and it is A times B. Okay. So this is, and we know that because this is a 2x3 matrix, right? And this one is a 3x2 matrix. So inner ones match, the outer ones are the new dimensions. All right, so we multiply those together, and I trust everyone can multiply matrices together. There's my work, and then let me talk about the answer. So check this out. These match. This might be coincidental. I'm not sure if they need to be the same label or not, but in this case they do. That might be true for your problem on the test. I don't know. But, the 3 and 3 match. The outer ones, that is your solution labeling. So style by color. So the rows is the style, and the columns, those are the color. So when you get your answer, you want to label that. Style and color. So rows, that's the style. Columns, that's the color. So, these blanks right here. So the rows represent the style. So that style would go here. And then the columns represent the color, and that would go here. And then you're also going to have another blank where you actually have to enter the answer that you get. So you have to enter your solution, the product of these two matrices. So that's it. Probably the hardest one on this test, just because word problems are notorious for being difficult for most, not most, but a lot of people. But you really need to break it up. You need to label stuff and just take it a step at a time. This is not part 2. This is on your test, part 1. All right, let's go to part 2 of your test. Okay. Part 2, number 1, here's the question that you'll have on your test. Again, I haven't uploaded the document yet. I will upload it later today. I just want to work these problems out just to make sure I don't have any issues with my equations that I created. So yeah, it says that solve the system by transforming your matrix into reduced row echelon form. State the solution as an ordered triple. So parentheses X, Y, Z, right? So make sure you have that in there. Show all work, no credits. I would suggest watching the recorded session from 9:28 at noon. I worked out one of these problems with a student in your class. And it's an hour-long session, so it goes very slow. You may want to watch it at like 1.5 speed or something. But we do work out one of these problems, and hopefully that helps. But you should also practice these problems in the modules, of course. Also, make sure you show all work. So every time you do an operation, I want to see the matrix that you came up with, and then to the left or underneath it, I want you to write the operation that you did. I read everyone's submission. I read, especially this problem, I read every single step that you do, and I verify the math that you have written down is correct. Because if I discover in one of your steps your math is wrong, however, you miraculously fixed your mistake and the subsequent 2 or 3 steps to get the right answer, I'm going to question if you actually did the problem or not yourself, or if you copied somebody or somewhere online, and I won't give you credit. So if I see mistakes in your work, you will not get credit regardless of having the correct answer. I am also looking for the initial setup of your matrix, all your steps that you do, and I believe you can do this problem in 9 operations to get to the answer. And then, of course, once you finish the problem, reread the question. It wants you to state the solution as an ordered triple. If you forget to do this step, it's on my rubric. You won't get credit. All right. Hopefully that answers number 1 on part 2. Again, you might want to watch this video. Okay, number 2 on part 2, probably the easiest question. All you got to do is multiply these 2 matrices together. That's it. Of course, show your work. If you go right from this to the answer, you're not getting credit. So show your work. You don't need to actually write down, I did -1 parentheses 1 plus 3 parentheses 3 plus 0 parentheses 5, for example. If you just want to do like -1 times 1 is -1, write that down, plus, and you did 3 times 3, you wrote a 9. That's okay. You don't have to show that that very detailed stuff, right? Of actually writing, -1 times 1, which I talked about in class already. So, but I am looking for, that work and that setup, and also your final solution. So, again, no work, no credit. It should go without saying. All right, number 3. This one, I'm giving you 2 equations, 2 unknowns, and we want to solve this using the inverse matrix method. And we did that yesterday. That was our last lesson. So if you want credit for number 3, you must use this method and show all work. So my rubric, I'm looking for the setup of your matrices, right? So you might want to review this. I'm looking at the setup of all your work. I'm looking for your determinant work. I'm looking for the inverse work. I'm looking for the setup of the equation, and then the flow of work to solve it. And then I'm also looking for the answer written as an ordered pair, x comma y. So again, if you do not use this method to solve and show me your work for this, you will not get credit. Now, if you want to, like, I don't know, maybe graph this in Desmos to give you the answer. So it's kind of nice if you know what the answer is supposed to be. So yeah, if you want to use a different method, like graphing method might be really easy to do to get the answer. Or if you want to use like substitution elimination method, do that first, just for your own knowledge to know what the answer is going to be. And then, once you're done with this problem, you should know what the answer is. Again, guys, part 2 is I do take time. I do comment everyone's test, and I do read everyone's work. I also have a really good memory, so I do recognize if people have copied other people, or if they have copied the internet. So it's just like speeding, right? People speed when they drive. Some people don't get caught, and some people do. And it kind of stinks when you're the person who was speeding and you get pulled over, even though everyone around you seemed to be speeding too, right? So it's the same thing, guys. I can't catch everyone for cheating. Last unit, I suspected about 10 people cheated on part 2 of unit 1 test. I could only prove without any doubt, 5 of them. So, if you got caught, it stinks. Learn from it. But going forward, guys, I expect you to show your own original work. Don't help each other out on these. It is a test because, if you do help people out on their part 2s, there's a chance that your work will look like your work possibly. And I may recognize that. And that kind of stinks if I do, right? Because it just makes, it's a bad moment, right? But no grudges if it happened to you in unit 1. It's fine. Just going forward, do better. That's all. Yeah, so the ones that I know without a doubt do that, I usually call them. And I say, hey, what's up? What's going on? What happened? But, if some people, it's just like a clear copy paste, like from online. And I search these online, guys. I do look these up online to see what's out there, and I commit the answers to memory of what I see online, and I see that on your part 2s, and I remember. So those people, I usually don't call them. I just put cheated in the comments, and then I just go on. I usually don't have time to call them. All right, so going on to the actual password. Before I show you the password, for part 2, please put all your handwritten work in a single Word document and then save it as a PDF. So you can take pictures of it using your phone, put them in the Word document, make sure you blow up the picture so it's a full screen per picture. And then you can go to File, Save As, and you can actually select PDF as an option. So once you have every image in the Word document and it looks good, you verified that it's not blurry, right? So it should be clear, and the images are orientated correctly. So right side up. I shouldn't have to turn my head sideways to try to read your work. So make sure they're rotated properly. So everyone should only have a single file uploaded for part 2 submission, and it should be a PDF. When people upload 6 different pictures, it makes it really difficult to actually grade and comment in your test. And also a lot of times, even though like on your phone, it's like right side up, but when you upload it, the JPEG, it's like sideways. It drives me nuts. There's also programs, apps for your phone to take pictures of your work, and it'll put it into a single PDF for you, like Simple Scanner, Tiny Scanner, and some other ones. And I don't know what Inkscape is. And I haven't heard of Krita. I never heard that either. Apparently those might be options to look at. I don't know. Oh, it's digital art. Okay. Yeah. So, all right. The password for part 1 of the test. Upload part 2 as PDF. Lol. It is case sensitive. All right, so remember, you have, if you want to do it today, you can, but I have time set aside. So tomorrow you'll be doing part 1 of this test during class time. On Friday, you want to use class time to do part 2. So then on Monday, we will do the review for your midterm. And I believe Monday, we're doing review and you have to do the test in the same day. But here's good news. The midterm is super easy. Like I think I made it too easy. But just so you know, the midterm is on Monday. It will probably be the easiest test of your life in this class. So don't fear the midterm. We'll go over it on Monday for it. All right. Anyway, well, everyone, thanks for coming, and good luck on your test tomorrow or today and Friday. And I will see you all Monday. If you have any questions on this test, feel free to message me a screenshot of what's going on, and maybe needs me to kind of point you in the right direction. I'm okay doing that. So yeah, don't feel like you can't message me about your test. I prefer Skype. I usually respond pretty quick, as long as it's after noon. But yeah, just screenshot and question. And yeah. All right, good luck, everyone.